everyone. My name is Sandhya Avasthi. I'm assistant professor in ABES Engineering College, Ghaziabad. I'm going to discuss the string matching problem today from the subject Design and Analysis of Algorithm. So in this video, I'm going to discuss what is string matching problem and naive string matching algorithm, one example on it, and discussion on time complexity. What is string matching problem, or also known as searching problem? So string searching algorithm are built mainly with the focus that if we need to find a pattern from a given text, we are able to do it. So finding a pattern within a larger string or text. So example of string searching is when a pattern and the search text are array element of an alphabet set, which is a finite set sigma. That may be a human language alphabet. For example, a string is made up of letters from A through Z. So what is naive string matching algorithm? It is a brute force approach. So also it is known as naive string matcher. So here the procedure finds all valid shifts. Also you can call as indexes where a match is found. So it goes through a loop. So it checks the condition, pattern, P 1:m, where m is the length of the pattern P and text is represented by T. So say a particular place where the match is found, that is represented by T s plus 1 to s plus m, where m is the length of the pattern. So for each possible value, that is n minus m plus 1 for S. So this is the algorithm. There are mainly 3 steps. So this is the loop where we start from the first index, that is 0, in the given text T. So the input to the algorithm here is T, text, the pattern P, length of the text N, and the length of the pattern M. So for this loop, we start from the first value, that is 0, and we go up to n minus m. And then at every step, we try to match. So this step goes around n minus 1m time. And this step, in worst case, there are m time it goes. Right? So this is the basic algorithm of naive string matcher. Let's take one example. So this is the discussion on it. So it takes n minus m plus 1 into m in worst case. So this is for the loop, and m is for the where we are matching the character from text T to pattern P. So for each n minus m plus 1 possible shift S, the line will execute m times. And in worst case, we say that pattern length is equal to n by 2. So that makes a worst case, and that will be in scenario where text is given, that is of this type, and pattern is of this type. So you may call that if T is given to be of this type, where it is a repetition of a single character, and where pattern is of this type. So in this situation, we call this sort of example we call as worst case. And in this case, if say we assume m is to be equal to n by 2, so this makes the worst case. And in this case, the complexity is order of n square, right? So in worst case, the time complexity of naive string matcher algorithm is order of n square. So let's take this example. So here, this is the text that is given, AC, AA, BC, and this is the pattern P. So pattern is AAB. So in this naive string matching algorithm, we start from the first character in text and then match it with the first character in P. So in this case, this is a match. Then the cursor move to the next value here and also the next value here. So we try to match C and this. So this is not a match. So what happens? It shift to the next character. So in next case, the pattern shift to this position and the next character in text is matched with the first character in pattern. So here also there is no match. In this B step, there is no match. So then it goes to the next shift. So that becomes the step C. So now the third character in text T is matched with the first character in pattern. So here this is a match. So both the values shift to the next point. Here also, because the first character is a match, so we move to the next character here as well as here. So this is also a match. So we move to the next character here and next character here. So this is also a match. So here, this part of the sub pattern in the text matches with this pattern. So S is equal to 2. That means in the second shift, we got a match. So this is your possible answer. And because it's not, still we have not reached to the end of the text. So it goes one more time and it shift one position right. So here A is matched with A, then B does not match with A. So now this process will stop because we have also, there's no going further in this. So we got our answer. So it returns the value S is equal to 2 as our answer. So this is a naive string matching algorithm. So this is our answer. Now I'm going to take another example. Suppose the text that is given is a string of binary digits 0 and 1, and the pattern P that is given is to be 1, 1, 1. So here we have to find all valid shift S. So that means all the value for S where we are getting a match. That means we are finding our pattern P. So the first shift, when S is equal to 0, both the characters are checked. So yes, there is a match. We move to the next character here and next character here. So there is no match. So the pattern shift one position right. So that will be our next situation. So for the value of S, when we shift one position right, so now the next value is match. So 0 is not equal to 1. So there is no match here. So it goes to the next shift. Now pattern moves one position right. Now we are, this is aligned here. So the character here is a match. Here also there is a match. Here also there is a match. So we get our match at the value of S is equal to 2. Now we have not reached at the end of the string yet. So this process will keep going. The entire loop will complete. So the next, it moves one position right. So the first character is a match. And the next character is also a match. But here, 0 and 1, this is not a match. So at shift 3, we don't find our match. So the pattern moves one position right again. Now pattern moves one position right again. We say 1, 1 matches. So there is a match. Now shift to next value. So we see that 0 and 1, they does not match. So this does not match actually here. So for S is equal to 4, there is no match. Now pattern moves one position right. So it's now we are here actually. So for S is equal to 5, we see 0 and 1, they do not match. The first occurrences even does not match. So we do not get our match here for shift 5. Now we are not yet reached at the end. So it goes one more time by shifting pattern one position right. So here we see the 1 matches with the 1, 1 matches with the 1, this 1 matches with the 1. So here we found our match for the value of S is equal to 6. Then we have not yet reached at the end. So this pattern moves one position right. And here we see that for this value, we see the last value does not match. So for the value of S is equal to 7, we do not get our answer. So what are the valid shift here? So valid shift is this one, S is equal to 2, and for S is equal to 6. For these two values, we get a match. That means these two are our answer. So that will be all in this video. The content for this PPT is taken from Introduction to Algorithm by Thomas H. Corman. That will be all. Bye-bye, everyone.